Have you ever wondered what your brain sounds like when you're floating between wakefulness and dream? What that dreamy, creative, deeply calm state actually looks like on a monitor? The short answer? Lots of theta. And scientists can measure it, pretty precisely, if you know what to look for. Theta is a brain rhythm. It's not mystical. It's electrical. It usually lives around 4 to 7 cycles per second in most human EEG studies. But here's the catch. It's messy. Different parts of the brain make different kinds of theta. The hippocampus has its own theta signature. The frontal midline, the part that lights up when you're focused internally, makes another. They can overlap in frequency but mean very different things. First, the basic picture. When researchers put electrodes on your scalp and look at the raw signal, they break it down into frequency bands. Delta is very slow. Theta sits just above that. Alpha is the classic relaxing eyes closed rhythm. Beta and gamma are faster. For meditation research, theta matters because it often increases during deep relaxation, creative insight, memory encoding, and that absorbed feeling meditators describe. In my experience, listening to many of these recordings, theta is the sound of inward focus. Calm but alert. Now here's where it gets interesting. There are at least 2 major theta signatures people talk about. One is hippocampal theta, which in animals is a pretty regular 6 to 10 hertz oscillation during movement and REM sleep. In humans, hippocampal rhythms are slower and more variable, sometimes half that frequency, and you often need intracranial electrodes to measure them directly. The other is frontal midline theta, a rhythm you can pick up on the scalp around the forehead and midline areas. That one shows up during focused attention, working memory, and many meditative states. So how do scientists actually measure theta? It starts with good data. You need EEG or MEG. EEG is accessible and cheap. MEG is cleaner for cortical sources but expensive. If you're serious and want the gold standard, intracranial recordings, electrodes placed directly on or in the brain, give the clearest picture. But for most meditation studies, scalp EEG is the workhorse. The first technical step is pre-processing. You filter the data to remove slow drifts and high-frequency noise. You remove artifacts, eye blinks, muscle activity. Even the tiny electrical spike from a jaw clench can hide or mimic theta. Researchers use a combination of visual inspection, independent component analysis, and external sensors for eye and muscle activity to clean the signal. You can't claim a theta increase if it's just someone nodding off. Next comes spectral analysis. Scientists use Fourier transforms or wavelet transforms to decompose the EEG into frequencies over time. That gives you a power spectrum, essentially how much energy sits in each frequency band. A common method is Welch's power spectral density for steady-state analysis and Morley wavelets for time-resolved tracking. If you see a bump in the 4 to 7 hertz band during meditation compared to baseline, you might call that increased theta power. But power is only one piece of the puzzle. The phase of an oscillation, where the wave is in its cycle, matters a lot too. To study coordination between brain areas, researchers compute coherence and phase-locking values. Coherence tells you whether 2 regions are oscillating at the same frequency and with a consistent phase relationship. Increased frontal occipital theta coherence during meditation suggests different brain areas are talking more coherently at that rhythm. And then there's cross-frequency coupling. This is one of my favorite findings. Theta often couples with gamma, the faster activity linked to local processing. When the amplitude of gamma is modulated by the phase of theta, it looks like slower theta waves are pacing bursts of fast processing. In memory research, theta-gamma coupling is thought to help organize sequences of information into discrete chunks. Some meditation studies report stronger theta-gamma coupling, which could explain why people sometimes report sharp moments of insight or vivid imagery while meditating. I should pause and mention a critical confound: drowsiness. Real theta from focused internal attention looks different from theta produced by falling asleep. Sleep-related theta usually comes with a collapse of alpha, increased slow waves, and behavioral signs of reduced responsiveness. Meditative theta, especially frontal midline theta, tends to appear while people remain alert and responsive. Scientists control for this by including behavioral probes, vigilance checks, and by recording respiration and muscle tone. Another caveat: scalp EEG gives you limited spatial resolution. Volume conduction means a single source can affect many electrodes. To estimate where the signals originate, researchers use source localization algorithms, beamforming, minimum norm estimates, Slorita, and when available, combine EEG with MRI anatomy. MEG helps too, because it's less distorted by the skull. But the takeaway is this. Claiming the hippocampus generated a scalp theta increase requires careful modeling or intracranial confirmation. So, what does the evidence say about meditation specifically? Across many studies, long-term meditators and short-guided practices often show increased theta power, especially in frontal midline regions. There's often increased theta coherence across frontal and parietal areas. Some studies show enhanced theta-gamma coupling and links between theta power and subjective reports of absorption, vivid imagery, or memory recall. But effect sizes vary. Different meditation techniques, focused attention, open monitoring, loving kindness, produce different EEG fingerprints. Focused attention tends to boost frontal midline theta. Open monitoring might show broader theta and alpha changes. How do scientists test whether these theta changes are meaningful? They use control conditions, baseline recordings, and sometimes neurofeedback. In neurofeedback, participants try to upregulate theta by watching a visual cue that responds to their brain activity. Some studies report improvements in memory or relaxation after theta neurofeedback, but the literature is mixed, and we should be cautious. It's tempting to think boosting theta will instantly give you creativity and memory gains. Reality is noisier. Individual differences matter. So does the quality of the signal and the training protocol. Let me tell you why this matters. Theta isn't just signal noise. It's a mechanism. It helps time when neurons fire, coordinate distant brain regions, and chunk information over time. In meditation, that may translate into better internal focus, more vivid imagery, and improved emotional regulation. For clinicians and researchers, understanding theta gives clues about memory consolidation, attention disorders, and even mood problems. If you want to measure your own theta at home, be realistic. Consumer EEG headbands can pick up big changes, but they are noisy. For anything rigorous, you need a decent sampling rate, at least 250 to 500 hertz, careful artifact control, and proper spectral analysis. Record a baseline with eyes open and eyes closed, monitor breathing, and if possible, include a simple cognitive probe to make sure you're not dozing off. Here's the kicker. Theta is subtle and beautiful. It sits at the edge of sleep and wakefulness, blending memory, attention, and feeling into a rhythm you can sometimes surf during meditation. It's not magic. It's electrochemistry, timing, and coordination. But when you see it rise on a screen or feel the state it accompanies, it's hard not to be a little awed. So what should you take away? Theta shows up during many meditative states, especially those involving focused internal attention. Scientists measure it with EEG and MEG, use spectral and phase analyses to quantify it, and take special care to rule out drowsiness and artifacts. Theta's interactions with other rhythms, especially gamma, may underlie why meditation can boost memory, insight, and emotional balance. And while consumer devices can give you a hint of theta, rigorous measurement requires real equipment and careful analysis. If this sparked your curiosity, try something simple. Sit quietly for 5 minutes, focus on your breath, and notice whether your attention narrows and images pop up. Then imagine what a 4 to 7 hertz rhythm would feel like inside that space. Slow, steady, organizing. If you want more, I can walk you through a basic EEG preprocessing pipeline next time. Raw data to theta power, step by step. If you like this deep dive, let me know which part you want next. The math behind wavelets, how neurofeedback really works, or a guided theta-enhancing meditation you can try at home. Stay curious. Keep listening to your brain. It has a lot to say.